This meeting is being recorded.
So welcome participants once again. So we can move on to the second session of today's. Our second session topic is implementing QML in industry. So it will be taken by Mr. Dhanasekar Balasamy. He is a seasoned professional with extensive experience in digital design and engineering. He currently serves as a staff in digital design engineer at SiMa.ai, where he works on cutting edge system on chip designs and intellectual property development for embedded edge ML and AI devices. Mr. Dhanashekar began his career in the VLSI domain with Mbit Wireless Private Limited, where he spent nearly 4 years specializing in SoC design, IP design, and memory controller architecture. He then joined Microchip Technology India Private Limited, where he contributed to the development of 8-bit microcontroller products. His journey continued at Intel in the EPG group, where he worked on Ethernet controllers, particularly focusing on queue classification mechanisms. In his current role at SiMa.ai, Mr. Balasamy is deeply involved in developing innovative solutions that integrate machine learning and artificial intelligence capabilities at the embedded edge, driving advancements in the field of intelligent systems. With his wealth of knowledge and hands on expertise in VLSI design, SoC architecture, and embedded systems, Mr. Balasamy brings valuable industry insights to today's session on quantum machine learning application. So thank you so much for accepting our invitation, Mr. Dhanshekar, and welcome you to the session.
Thank you, Dr. Shilpa madam. Yeah, thank you. Thanks for the opportunity. Yeah. Shall we start the session?
Yeah, you can start the session.
Yeah, sure. Um, Please let me know once the screen is visible.
Yeah, it is visible. You can make it a full screen.
Yeah, sure. Now it's in the full screen, right?
No, you can click on the slideshow. Bottom at the right, bottom right
Uh,
side.
no, it's already. Now you can see the or
Yeah,
still.
it's slow.
Yeah.
Actually, slowly it is moving. It's still showing
Okay.
normal PPT mode only. It's not in a slideshow.
Just a minute. Wait, I'll scare my entire screen so that it will be.
Yeah, now it is fine.
I hope now. Yes. Okay. Yeah.
Yes.
Sure. Okay. Yeah, shall we start the session, right? So, okay. So I'm Dhanasekar. I think Dr. Shilpa madam introduced me, right? So I'm into digital design in the industry, in the semiconductor industry. I think she covered pretty much everything. So I'm directly going to the topic. So we are going to see implementation of quantum machine learning in the industry. So how industries are evolving to adapt the quantum machine learning. So, what are all the different uh, techniques we need to adapt for the quantum machine learning in the industry? So, different what are all the challenges we might face in the implementing the quantum machine learning? All those things we are going to see in the upcoming session. So today our agenda is today going to see the artificial. I mean the first two and three, right? So these are all the basic concepts. I'm going to just give a brief about it. Why? Because right. So this entire session from the starting from Monday, right? So it pretty much covered different expertise are covered at the machine learning part, quantum machine learning, quantum computing part, everything. I think the in-depth knowledge is transferred to you guys, right? So I'm just going through a just introduction or a overview of these three topics, and then we'll focus on the how we are implementing the quantum machine learning in the industry side. So yes. Okay, so one more thing, right? Um, so I just wanted to be the session as a not a single way communication, right? So it will be a multiple. I mean, it will be a duplex, right? So we need to be a interactive. So that's the reason I introduced a session. I mean, introduced add-ons in the PPT. It's called Mentimeter. So if you have your mobiles on your mobiles or you are joined through your system, so you can just log into Menti www.menti.com, or you can scan this QR code and then you can put this code as a password, right? So you can go when I mean you can interact. We can do a interactive sessions, right? So that will be a very. I mean, it will be an interactive session. So please try to log in either on your mobile or your screen. So I will wait for a few minutes, and then we can start the session. So uh, this way, right? So it will be a two-way communication. So it will be very. I mean, it will be a nice to interact, right? So yeah.
Sure, I'll ask all the participants to read.
Yeah, I think maximum we can accommodate 50. Yeah.
Okay, okay,
Yeah.
no problem.
Yeah. Sure. You can use your mobile or a laptop or whatever the medium, right, you are using, so you can just connect through this one. Okay.
You need to log
I'll
for that Mentimeter.
Yeah, I mean you can log into this www.menti.com.
Okay.
Yeah, I see something. Some people are joining, right? So and then or otherwise you can enter this code. I mean, go to this menti.com and enter this code. Instead of that one, you can go with the scanning of this QR code. Either way, you can join this this session.
Sure.
So whenever we are going with the Mentimeter, you can just refresh your screen in your system or mobile, so that any questions or those things will be an interactive session. So yeah, I'll move on to the topic. So artificial intelligence. So this is a buzzword right now, right? So everybody, each and everyone, from kids to people, right? So everybody is talking about the artificial intelligence. So in every industry, the AI involvement, everything is a huge, and then it's changing the industry is very differently. So here, I mean, I'm just giving an introduction, like, so this is the, I mean, this is a very critical technology we need to adapt in each and I mean, every industry. So actually, what it does, right? So it actually, I mean, we less human interaction with the machines, right? So even in the everywhere, even if you take any kind of application, the human interaction needs to be very less, and then what are all the human intellectual things we can do through a machine, right? So that is an artificial intelligence. So if you go into the artificial intelligence, you can see like machine learning, deep learning, generative AI. It's a keep on so many buzzwords you can hear, right? So just giving a overview on the artificial intelligence, and then we'll see how it's transforming to our quantum machine learning, right? So we'll see that one. So just see your menti, that one. The I mean, you can see this picture, and then you can type what is the word comes to your mind, right? So you can see the picture. You can look into this picture. Actually, this picture is generated by AI based on our inputs, right? So you can see that one, and then you can just type a word after seeing this picture. What is the word coming to your mind? I hope everybody, I mean, everyone able to see the screen, right, in your phone or mobile, which devices.
Yeah, the screen is visible.
Yeah, sure. I mean, whatever, I mean, it's an anonymous only, so don't worry. Whatever you will feel, right? So it's nothing wrong about it. So you can just type. fever, male. Okay. Okay, Python fix. Okay. Okay. So the intention here is to write. So if you see the image, right? So we are seeing a huge. I mean, is we are seeing the ocean here. Inside the ocean, we have we are seeing the fish that is writing a code, right? So the intention of this picture, right? So AI can do anything. So which is I mean, whatever we are saying is an impossible, right? So that can be through that can be a possible through a technology called AI. So that is the intention of this picture. Yeah. Okay. Thanks for your responses. And then you can see what kind of machine learning is that. So I think you people are heard about the machine learning, different kind of machine learnings, right? So, so what is this? I mean, if you see the picture, right? So what is this machine learning belongs to? Either it's a supervised, unsupervised, or a reinforcement learning. Okay, actually, this picture is the unsupervised learning. So why? Because right, so the unlabeled training data is there, and then the machine is processing this data and then segregating based on this nature, right? So there is no. I mean, we in the machine learning we are classifying into an supervised, unsupervised. So this belongs to a supervised, unsupervised learning. Okay. So yeah, I'll go to the next slide. So okay, machine learning. So in the AI, right? So we have a lot of subsequent subsets. We have one of the main subset is the machine learning. So machine learning, right? So we are training the machines based on the data. So if I give an example, we are training our I mean kids, right? In the from starting from after birth, right? We are trying to make them learn everything, right? So it's the same kind of thing what we are doing for the machine. So that is called machine learning. So and then we have the deep learning. So inside machine learning we have deep learning, generative AI, all these things are coming. So the deep learning, what it does, right? So it's an one step ahead of the machine learning. It will work on the neural networks, or I mean analyzing the factors of multiple data, right? So it will be a very complex data, complex patterns. So those things can be analyzed through this deep learning. Okay, so then I mean, just we are going to see the generative AI next one, and then if you list down some few Gen AI tools, like what are all the generative AI tools you are using in your day-to-day lives? So many tools you may use in your day-to-day life, right? So can you list few tools, like what are all the generative AI tools? OpenAI, ChatGPT, yes. Meta AI, Copilot, yeah. Okay, I'll move on to the next slide. So generative AI, so it's a Gen AI. So it refers to the, I mean, what it does, right? So it actually works on the text, image, music. So even if you feed the, if you ask this generative AI tools to write some um, some music lines or lyrics, right? So it will try to write for you, and then even you can make a song out of it. So I have done those things, right? So it's a very very different landscape in the AI field. So you can utilize this generative AI in a very much more useful manner, right? So it will works on everything: text, image, music, or based on the pet based on this text to text, image to image, or voice to text. So everything it can, I mean, this through this generative AI, so everything can be possible. So this is a huge vast topic. I'm just giving a one line just overview, since you have gone through all these in-depth sessions earlier, right? So I'm just giving a one liner. So now like quantum computing. So I mean, quantum computing is the like AI is the now buzzword, right? So the future is based on the quantum computing. So what quantum computing is, right? So it's working based on the quantum physics. Like, so the classical computers will work on zeros and ones, two states, but the quantum computer, how it is different from classical computers, right? So it will be on the I mean, in the quantum world, the bits represent as a qubit, so which can be zeros and ones. But the main difference here in the quantum computer is, right. So these two states can be exist in multiple. I mean, if you go with the one bit, right. So it will be two states. It will be exist in both the states simultaneously. So that is the uh, um, major difference in the when compared to the classical computing versus the quantum computing. So that is the superposition. So we have different concepts like superposition, entanglement, quantum interfaces. So through this quantum computing, I mean, we are solving complex issues, data, complex data, right? So we can make it very quickly as soon as, I mean, it's a very huge data. Also we can process it very in a when we compare to the classical computing, right? It's very much easy to compute all these complex data structures. So that is a major advantage of the quantum computing. So we'll have a question like, so will quantum computing replace classical computing? So till now, I'm just giving a overview of the machine learning, deep learning, or quantum computing. Why? Because, right, so it's already covered multiple times, right? So that's right. Yeah. We'll- yes. I'm seeing less responses only. I guess two or three. I mean, feel free to respond. Okay. So I think based on the responses, people are saying yes, but actually the answer is no. Why? Because, right, so the quantum compute, I mean, classical computing is required for a different purpose, and as well as the quantum is an advanced level. But anyway, this will not replace quantum computing. So based on the memories, all these um, hardware complexities, all those things in place, right? So classical computing is anyway required, so it will not replace the quantum computing. So even though quantum computing will go further, it will occupy industry. This classical computing will be there, so it will not replace. Okay. Okay, so we'll see the some basic difference based on the aspects, right? So how it will be differing from quantum computer is different. Computer is different from the classical computing. So the basic unit, right? So we are saying it's a bits, zeros and ones. In the quantum computing, it's a qubits. Here also it will be the same zeros and ones, but it will be in the both state in simultaneously. That is the major difference, right? So And then processing method, it's a sequential processing. So in quantum, it's a parallel processing. That is the reason why we are able to process a lot of complex data in a very quick manner, and then we can able to make a decision in a very faster manner in the quantum computing. And then the nature of computation, classical physics principle. Here it's a quantum mechanic principles. And then speed wise, right? So as I said, based on the processing method, the speed is classical computer is linear, and then it's a quantum computer, it's an exponential, right? So even if you see the classical computers, so we are trying to make it parallel processing, but actually what we are doing, right? So we are adding additional cores into our system to make it parallel, right? But eventually if you take a one core at a time, it will be a sequential process. So that's the reason in the classical computing we are adding much more cores into the system, so that it will be the performance of the particular system will be very much faster, right? So that is the reason we are adding multiple cores in the SoC. So if you take a quantum computing, the growth, I mean, since it's parallel processing, how it gets a parallel processing capacity is based on the superposition. Why? Because, right, so it can be in both the states. I mean, it can exist in the both the states, right? So that is the very big advantage in the quantum computing. So due to that advantage, we are doing the parallel processing. So with the parallel processing, we this speed of this particular system will be an exponential growth, not in the linear way. Okay. So algorithmic approach, right? So it's a classical algorithm. So here we have the quantum algorithms, and then error correction. I mean error correction in the in the classical computing, right? So established techniques. So we have like CRC, and a lot of techniques are there in the classical computing. And then if you take a quantum computing, I mean still some of the so if you see the IBMs, right? So even they are making different ways to do the error correction in the quantum. So if you increase the number of qubits in a system, so the noise and error is a major disadvantage, right? So it limiting the number of qubits in the system. So that way, the error correction in the quantum computing we need to reduce, right? So that is these are all the major difference between the classical and quantum computing. Okay. Okay. One more question. I think if you have three qubits, okay, how many states can be represented in the quantum computing? If you take a classical computing, if you have 3 bits, so it may go up to 8 different states, right? So in case of quantum computing, how many states it can take for the given 3 qubits? I think here the scales will be there. Like you can put some 5, 10, or if you are confident of, you can put 10 kind of thing. But this is the um, I mean number of number of states can be represented based on the bits, right? So in classical computing, in the qubits, so how it will be? How many states for the 3 qubits? I'll wait for another minute, so maybe so that you can think and answer. Right. So based on the responses, right, I see it's towards three number of states. But if you take a classical computing, 2 power n, right? So 2 power n, it's 8 bits, right? Even if you have the three qubits in the quantum computing, it will be the same 8 states. But the different is it can be exist in all the states simultaneously. So that is the difference. So number of states wise there is no difference. So how, at a given point in time, how many states can this can be exist in how many number of states? That is the difference in the quantum and the classical computing. So for both classical and qubit, for a given three bits, it will be 8 states only. I see there is no. I think only few answer like 8 bits. So everything, everybody is related to three, but yeah, three is not a correct one. So it's 8 bit. Even we cannot say it's an infinity. So based on the number of qubits, it can go up to different states, 2 power n different states, but it will be there in the exist in the all the states simultaneously. Okay. So we'll come to our original topic. So quantum machine learning. So as name says, right? So quantum machine learning. So we are integrating two different, two different thing, right? So one is quantum computing and then the machine learning. So machine learning is as of now we are using a classical machine learning algorithms or a classical machine learning, and then we are towards progressing towards quantum computing. So we are seeing a lot of advantages over classical computing in the rather than the quantum computing. So we are seeing a lot more advantages in the quantum computing. So if we leverage the quantum computing principle to the machine learning, so how it will looks like, that is the quantum machine learning. So what are all the advantages in the quantum computing that we are taking for the machine learning applications? So machine learning is already a very what I say. So it's a very critical field that is taking a lot of advanced technologies, right? So based on the technologies, it's try to um, simplifies the human work, right? So it's fastening the human decision making things, identifying faults. So based on the different models, it's identifying the different things in a very short, very precision time. Very precisely, and then within a shorter duration. So we have a lot of advantages in the machine learning. So we have a lot more advantages in the quantum computing. So runtime, or so many advantages we are having in the quantum computing. So if we leverage both the things, then we can get much more beneficial in the quantum machine learning. So that is what the quantum machine learning. So we'll see how it's going, right? So okay. So one more question, like hybrid combination of quantum computing and classical computing is possible. Like for example, earlier we said quantum computing will not replace classical computing, but hybrid is possible or not, right? So it will not replace, but whether hybrid is possible. Okay. Okay, I think everyone is aligned with this, right? So since quantum computing will not replace classical, so then that solution will be in hybrid only. So okay, hybrid is the possible. So that is the very nice take from this thing, right? So we are not leaving the classical computing, and then we are utilizing the quantum computing advantages, right? So integrating both the things, it will give a much more beneficial things, right? So some of the advantages we are take it from the quantum computing, and then from the classical computing, and then much more we are taking from the quantum computing. Okay, so we'll come to the topic, like, so why quantum machine learning is required, like what is the advantage, or why it's required. So we are seeing what is quantum machine learning. So why the quantum machine learning is required, like, so these are all the different reasons. So we can say due to these are all I'm listing different reasons. So due to these different reasons, we are saying the quantum machine learnings are required for our system, right? So why? So we can see improved runtime. So I mean, so if you run some models in any of the in any AI machines, right? So if you have a lesser time, within the lesser time, if you make a quick decisions, right, that will be an advantage, right? So we can process everything we can make it faster, right? So that will be saving a lot of time, and then that will be moving ahead, right? So that will be the main advantages. So improved runtime will be a very much advantage in the quantum machine learning. That's why we are utilizing the quantum machine learning, right? So then we have the enhanced learning capacity, and then the greater learning efficiency. Like for example, uh, if you take a machine learning models or something, right? So there we need a very less training data, so when compared to the classical, right? So based on the lesser number of training data, we can make a very quick we can make the decision very quick, and then we can make a better results when compared to the classical computer, right? So classical machine learning. So that is one more added advantage in the quantum machine learning. And then handling the complex structures. So why it was very easy in quantum machine learning, right? So due to the parallel processing, so handling the complex structures, right? So it will be very easy, like complex data. If you take a finance or a molecular and then the drug, right? So these are all the different fields, right? So lot more of data we need to process, right? So there the quantum machine learning can be leveraged very much, so that it can be, I mean, we can make if you want to get a quicker results, we can use machine learning, right? For example, if some model producing the results for the complex data within 10 hours, when we compare to the this is classical machine learning. If you make use of the quantum machine learning, it make it in the just less than 15-10 minutes, right? So that is the advantage we are making out of the quantum machine learning, right? So then next, so so these are all the reasons why we are making quantum machine learning. This is an add-ons, right? So parallel processing capabilities, and then new insights and data representation, right? So and then potential for exponential speedups. So like I mean, some of the task, right? So powerful tools or a powerful complex data, right? So that needs a very faster computational things. So that can be a added advantage if we have the quantum machine learning. When we compare to the classical machine learning, that will not be achieved through the classical machine learning. So that is the reason. So we are going with the quantum machine learning. And then the final thing is the application across diversified fields, right? For example, finance, logistics, drug discovery, and then supply chain management. A lot of, you can imagine all the industries, but right now these are all the major industries. They are adapting the quantum machine learning, so it can be diversified each and every fields of our day-to-day life. So that is the that these are all the different reasons why we required the quantum machine learning. Okay, so you can type, right? So few applications of quantum machine learning, at least I think you can think of, right? So other than the which I mentioned previous side. So you can think of different machine learning applications, right? So you can imagine, I mean, you can think of, I mean, even if you say it's a finance sector, so we can leverage these things into a very different categories also, right? So, I mean, finance is a huge topic. So inside the finance, we can leverage to different departments or different fields, right? So you can just okay, manufacturing, okay, good auditing, drug discovery, okay, health finance, okay, okay, I'm getting some responses. Okay, nanoparticles, yeah, true. Disease prediction, yeah, good. Okay, okay. So, yeah, yeah. I think everything, I mean, what all I'm seeing here, everything is perfectly and applications of quantum machine learning. Okay, so I'm listed a few here, right? So, one is a drug discovery and material science, and then another is a finance. So, logistic and supply chain management, pattern recognition, climate modeling. It's a new thing, right? So, climate modeling, identifying the weather, right? So, and then cyber security, even quantum machine learning after QML coming, right? So cyber security also plays a key role, right? So we can break the passwords very easily, very quickly, right? So due to the, I mean, due to the, I mean, it's based on the quantum machine learning advantages, but we need to have a different mechanism to make cybersecurity live, right? So, and then we have the simulating quantum systems, right? So these are all the different applications we can use the quantum machine learning. So we'll see each and everything in detail in the latest slides. Okay. Okay. So I'm QML. I mean quantum machine learning implementation strategies. So Um, so we see what is quantum machine learning. So why quantum machine learning is required. So we see uh, we identified what are all the reasons. These are all the reasons. That's why I'm implementing quantum machine learning. So how I can implement, so we can see later, and then now we are seeing it. I mean, what are all the implementation strategies we can make it for the quantum machine learning to implement in the different industries, right? So right now we are not integrating this quantum machine learning because this is a new technology is coming, right? So I mean, how we can implement these strategies, right? How we can implement the quantum QML in the industries, right? So a few strategies I listed, right? So collaboration with the quantum startups, like we have Cambridge Quantum and then Quantica Computer. So these are the two different startups. Are we have much more startups are there, and then even IBM, Google, everybody, every big player, right? They're in the quantum world, right? So collaboration with the quantum startup is one more strategy. For example, we are in the some industry. For example, we are in the automobile industry or we are in the manufacturing industry. So how we can implement these quantum machine learning algorithms, right, sir? So we can since the hardware cost and then um, I mean, the idea wise, right? So we are in the very starting stage. So, uh, to make it use, I mean, to make use of the quantum machine learning, we need to collaborate with the quantum startups. So that's way we can implement, at least we can start implementing the quantum machine learning in our industry. And one more thing, so hybrid approaches. So uh, as we said, right, so in the earlier side, one of the question we asked, right, so whether hybrid is possible or not. So it's possible, right, combining classical and quantum computing techniques, right, so that allows, right, so leverage, uh, I mean, in the existing industry, right? So we gradually increased into the quantum. I mean, maybe we can. We are right now. We are in the classical computing world, and then classical machine learning strategies we are using in our industry. So we can leverage the few things to the quantum machine learning. So that's way we can take use of the quantum machine learning in our industry, right? So the transition has to happen. So we can start. I mean, within a single day, it won't change. So I mean, it's a linearly we need to adapt the quantum machine learning. So the hybrid approach is the best approach, so that we can slowly move to the quantum machine learning in our industry, right? So any of the industry, right? Okay, and then investing in research and development, right? So I mean, this quantum machine learning concepts are very in very early stage. Even IBM making the lot of qubit chips. Even Google, they are in 127 qubits. They are making one 127 qubits, right? Silicons, right? So everybody's research, every major organizations are doing the research and development in the quantum machine learning. So at least we can utilize a few things from them to implement this quantum machine learning, so that we can slowly migrate to the quantum machine learning. But anyway, it will not. I mean, classical machine learning is needs to be there. Why? Because, right? Sorry. So what are all the process we are doing in the quantum machine learning? At the end, if you try to measure, we need a classical machine learning. So if we try to measure, right, so the quantum superposition will not be there, and then we need to either it will settle down in any of the states, either it will not exist in all the states if we try to measure. So that's way the classical computers need is very much required. So these are all the different strategies we can work on, right? So to implement the quantum machine learning in our industries, right? In any of the industries. Okay. I mean, I'm moving a little bit faster, or I think the face is okay, or I can slow down, or I can make it faster, or how you're feeling? Any? Hello?
It's going good.
Ah, okay, 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 okay. Thank you. Okay, so in the QML, we have a lot of, I mean, the implementing quantum machine learning. So we can see a lot of industries we are seeing in the lot of industries, right? So one of the industries I have mentioned here is logistic and supply chain. So in the logistic and supply chain is the huge topic, right? Or a huge thing. So in this logistic and supply chain management, what are all I have listed few things in that one. So we need to identify the various opportunities in this thing, and then you can just see what are all the uh, I mean, what are all the places where we can implement the quantum machine learning in the logistic and supply chain management, like route optimization, demand forecasting, supply chain risk management, predictive maintenance, and then the process monitor. So in where, I mean, these are all the different techniques in the logistics and supply chain management. So which areas we implement the quantum machine learning. Okay, so I see three different answers, like route optimization, demand forecasting and supply chain risk management, and one more is the predictive maintenance. So these are all the four different categories. Right now, we can use the quantum machine learning for the implementing the quantum machine learning all these different fields in the logistic and supply chain management, right? So these are all the different categories, right? Route optimization. So we can see what are all the advantages here. So like based on the route optimization, right? So we can save time, money, all these things are involved here in the route optimization, and then the predictive maintenance, like supply chain risk management, all these things are the very key areas in the logistic and supply chain management. So due to implementing, I mean, with the help of quantum machine learning, we can achieve a lot of, we can make it faster. We can save a lot of money, so it will be huge advantages in this industry, right? So okay, I'll go to the next slide. So various opportunities for the opportunities for implementing quantum machine learning. So we are seeing, we have seen why we require a quantum machine learning, and then applications of quantum machine learning. In we have seen like finance, logistic, and supply chain as a one-liner, right? So in these different kind of industries, what are all the various opportunities, right? Finance is a huger industry. So in the finance, what is the specific department or a specific thing I can implement the quantum machine learning, so that what are all the benefits I'm going to get? So we can see that one. So in the drug and material science, so we are having a molecular simulations, right? So if due to the implementation of the quantum machine learning, so we can able to identify the novel components quickly, and then the simulations we can make it in the faster in the chemical spaces, right? So this is very much required for the drug discovery. So the new drug discovery is there. It will take lot of simulation, lot of time to identifying the new drugs. So with the help of this quantum machine learning, so drug discovery is very much beneficial here, and then the identifying the new components quickly. So that is one more advantage here. So these are the areas where we can implement the quantum machine learning. So in the financial sector, we can see portfolio optimization. So I mean, we can, in portfolio management, right? So we need to maintain n number of stocks or n number of things, right? So in our portfolio, so if we go and analyze each and every stock, so it's keep tracking on all the stocks will be a very hectic thing. We cannot remember everything. So even if you make a note of it, so we need to go and see, check periodically, and then we need to update all those things for the portfolio, right? Portfolio optimization or portfolio management kind of thing. So with the implementation of the QML in the portfolio management, what we can do, right? So we are taking a balance risk, and then more efficiently we can take the stocks or portfolio, right? So we can able to manage the portfolio very effectively, and then with the balance risk, even we can identify the potential of the stock in the future based on the past data, right? So we can utilize in the stock market also, right? So we have a lot more data to, based on the particular industry, we have a lot more data to process. So all based on those data in the past, so the quantum machine learning able to predict the future of this particular company, right? So that is one more major advantage, right? So using the quantum machine learning, so these are all the different opportunities. So these are all the, in the finance, we can utilize the portfolio management and then risk management, right? So risk wise, so as a human or some algorithms, right? So we can, I mean, the accuracy is very less, and then decision making also, it's very much complex in those areas, making a decision, right? So with the help of quantum machine learning, we can make the accurate predictions, and then we can reduce the investments risk in the portfolio. I mean, in the financial sectors. So I'm just listed two here, right? So we can utilize many more different types of industries in the sorry different departments in the finance. We can utilize these QML, and then we are going to we are seeing the logistic and supply chain management. So as we see earlier, I'm just mentioning one here. So one is the route optimization. So with the help of quantum machine learning, we can do a route optimization based on the data, everything, right? So what it does, right? So based on the route optimization, minimizing the cost. Why? Because if we get a very shorter path, right? So that will save everything, right? I mean, transportation days. So everything we are saving. So maximizing the efficiency will be higher, and then the uh, minimizing the cost which we are spending on the transportation, right? So that is one of the advantages. And then we have the demand forecasting, and then supply chain risk management. So in the supply chain, a lot of risks involved here, and then so those things also can be achieved through the quantum machine learning. And then the predictive maintenance. So maintenance wise also we can be very much aware, right, in the logistic and supply chain management. So we can implement the quantum machine learning with which each and every industry in a very useful manner, right? So we'll see even in the pattern recognition, right? So in the generative AI, we are using the image speech recognition or natural language processing for all these different applications. These are all the various opportunities, right? So if you take any field like finance, logistics, or drug recovery, material science, in each and every field, at least we can implement the quantum machine learning in any one of the department in the different industries, right? So I listed four here, and then we can see a few things in the next slide. Like for example, these are all additional things like climate modeling. So this is a weather prediction mechanism right now we are having, right? So even sometimes, right? So um, we are not able to predict as accurately the weather, right? So sometimes it's a false prediction also happening due to the I mean inaccuracy, right, in a system, right? So there it will be very much useful, like so this climate modeling can be enhanced based on the past data. So I mean, if you see the past data, right, it will be very huge data will be there. So to process that huge data, we need a quantum machine learning. Why? Because if you make it in the classical computing, it will take lot more time. So we cannot make a prediction, right? So it's a time critical application. Like these are all the time critical applications, right? So if we miss the timing, then everything is prediction is waste here, right? So if we predict it later, then there is no use, right? So that's what these are all the very time critical applications. So for these time critical applications, if we implement the quantum machine learning, we are making lot more accurate climate modeling. So with a larger data set, with this one we can easily predict the climate, uh, and then how it impacting the ecosystem, right? So it will be very much easy, and then we can get the higher accuracy in terms of predictions. So we can implement the quantum machine learning in these areas, climate modeling, and then cyber security. So data protection is a very much worried one, right? So why? Because right, so every cyber security crimes are happening. Uh, very often we are seeing a cyber security hacks, right? So here with the help of with the help of QML, so it both ways, right? So we can easily break the system, or we can make it more more secure. So we need to implement the QML to make our system very more secure and secure. So data protection wise, it's very much useful. And then it can be, I mean, every technologies can be used in a positive or negative manner. So we need to use it in a positive way, right? So that's what cybersecurity is a very important key concept in the quantum machine learning. So and then simulating the quantum applications. So for the research applications, right? So if you run a powerful tools uh, in any of the any, for example, if you take a material science or a physics or a chemistry or any research and development oriented quantum systems, right? We need to run some simulations to see the results. So it will take a lot of time, right? So we need to run a powerful tools by the way to get the results. So those things can be achieved through the quantum machine learning. Okay. Um, See, so quantum machine learning is possible in automotive. So we are seeing different applications like finance, drug discovery, logistics, cyber security, everything we have seen earlier, right? So where we can implement these are different industries we can implement the quantum machine learning. So whether quantum machine learning is possible in automotive, why? Because right, we need to have a lot of certification in the automotive, like functional safety wise we need to have functional safety. um, those is very complex in the system. In the classical machine learning itself we need to have a functional safety certification process, right? So that will be a huger involvements in the automotive sector. So whether why? Because right, so if some error is happening in the automotive, so that will lead to a death, or I mean it will be a this loss is very huge, right? So that's the reason automotive is very critical area. So that's the reason we need to be very careful about it. So whether QML is possible in the automotive, that's the reason I have a question here. So whether it's possible to implement quantum machine learning in the automotive industry. Okay, I see. Yes. Okay, it's possible. By the way, I see strong yes. Okay, so yes, it's possible. Um, it's possible to implement the quantum machine learning in the automotive industry. So BMW and Airbus is the first automotive firm to take the. I mean, they are invested in the quantum computing. So they are doing a research in the quantum machine learning. So how we can leverage the how we can leverage the quantum machine learning in the automotive industry. So these are all the two different. I am taken these from their particular sources. So even the second point, so they have implemented a quantum machine learning solutions in the BMW at Vista. After implementing the quantum machine learning, so we are getting a 97% of accuracy in enhancing the classical algorithms, right? So this is from the source. I'm not sure about the rest of this one, but this is from the BMW. So they are investing in the quantum machine learning, BMW or Airbus. From this is from their official website. So they are making a investment in the quantum computing, right? So what they are saying, right? So they are in the still early stages. They are progress made in the challenge, right? So what they have made the progress in the quantum machine learning is, right? So based on the progress what we did till now, so they are seeing a very extraordinary advancement in the automotive industry. So basically what they are conveying, right? So they have started implementing quantum machine learning in the automotive industry. So based on the initial phase results, or based on the initial phase of the implementing the quantum machine learning in automotive, right? So they are very much um, very much satisfied, or very much uh, satisfied to see the full quantum machine learning in the automotive industry. So the potential is very huge in the automotive industry. So I mean, how AI changed everything, every in each and every industry, right? So that way, the quantum machine learning will also change the world in each and every industry, right? So okay, so we see like what are the various opportunities where we can implement the quantum machine learning in each and every department or each and every sector where we see where is the opportunity. So where can I implement the so that we seen earlier. So now we are going to see how to implement the quantum machine learning. So we've seen where is the opportunity, and then now we are going to see how we are going to implement the quantum machine learning. Okay, so identifying the relevant use cases. So this is a major thing. So if you take each and every industry, um, we have a lot more problems or a lot more process into the industry, right? So we need to identify the relevant use cases. For example, um, we need to use this quantum machining for the if you take a automotive production lines, right? So we need to take it for the some parts, damaged part detection, or it will be used for the painting, coloring, or identifying faults. Or I mean, we have uh, lot more things in the each and every industry. So there we need to identify the relevant use cases. So whether if I take a quantum machine learning, um, so I'm getting a efficient results. For example, few problems can be handled in the classical machine learning itself. So those things there is no need for upgrading to the quantum machine learning. Why? Because right, so it's a very costlier thing right now, and then there is no need for upgrading to the quantum machine learning. So if you see a potential advantage uh, in the implementation of quantum machine learning, then we need to move to the quantum machine learning, right? So we need to adapt those things. So how, right? So we need to identify the relevant use cases. Like for example, in industry applications, we have seen in the finance, each and every industry. So one or two different sectors we can include the quantum machine learning. So those are all the different sectors that request the quantum machine learning advantages, right? So the remaining things can be achieved through a classical machine learning itself. There is no need for the quantum machine learning. So we this is a very key point, right? So identifying the use case is the key here, right? So and then so we have the invest in the infrastructure and tools, right? So I mean, if you want to implement quantum machine learning, then we need to have an infrastructure and tools. So if the infrastructure, right, so the hardware and software platforms are the major things. So if you have the hardware, right, instead of initially go and have the hardware initially and spend a lot of time money in it, right? So if we see, we can leverage somebody else hardware, right? So through a cloud computing or through a cloud access, right? So whether we can leverage the instead of initially spending money onto the hardware or a quantum hardware, we can use the hardware access from the different cloud computing platforms or a different uh, I mean different people, right? So that way, instead of spending huge amount in the hardware, we can spend only fewer quantities in that one, so that in case maybe for example, if you are implementing the quantum machine learning for some applications, we are identified some application and then we are trying to implement. So for that one we need a quantum hardware. So we don't have the quantum hardware, so investment is a very huge thing. So after investing this one, so we are not seeing a better results or a better accuracy. It will be the R&D cost will be very much I mean, it will not be that much useful. So I mean, in the initial stages, right? So what we need to do, we can utilize the quantum cloud computing platforms, right? So that way we can That is a major thing. So why? Because quantum hardware is a very much costlier. And then we have the software platforms, like so as I said, the quantum hardware, right? So even the software platforms are already available in the market, right? From the Google and then IBM, I mean Qskate and then Cirric, and then lot of platforms are available in the market for the software platforms for the QML. So instead of investing in the initial stages, big investments, so we can utilize these things. Okay. So that way we can be in the safer side, right? Okay. Next. Okay. So and one additional things, right? So we'll develop hybrid solutions. So as we discussed, right? So we see what are the advantages if we have the both classical and quantum computing, right? So we can slowly migrate to the classical. I mean, for classical from the quantum, so we can split the different tasks, right? So which will be doing what, right? So those kind of approaches will help initially to implement the quantum machine learning in the industry. So and then the quantum classical workflow wise, so we need to have a workflow that will be very seamless interaction between the classical system as well as the quantum systems. So that way we can be the data can be transferred and processed efficiently. So when we are going for a hybrid solutions, so hybrid solutions we need both quantum and classical computing. So if you have a classical and quantum, so we need a interface between the classical and quantum computing, right? So that interface needs to be seamless interaction. So and then uh, through the seamless interaction, so we can able to achieve the process efficiently. The transition will be very much uh, very quick, and then we can able to achieve the efficient processing between the quantum and then classical. So with the hybrid solutions, these two different approaches will help to implement the quantum machine learning. Okay, so then we have the algorithm development. So we need to focus algorithm developments. Why? Because right, so I mean, so lot of algorithms available in the market. So we need to identify which algorithm will be suitable for your application. So that way we can utilize the already available algorithms for our system. So that way there is no need for the developing newer algorithm. So we can take it from the already available algorithms, and then we need a customization, right? So if required some customization also, we can do the customization in the already existing algorithm, and then we can make it for our purpose, right? So this way we need to be in the algorithm development. These are the two different categories, right? So we need to investigate on the existing algorithm, and then customize how we can customize for our use cases, right? So and we have another three points, right? So um, so these are all the implementation part. So we need to make sure, right? So this how we'll answer everything, right? So if I go for this one, so how I can implement here in industry. So hardware, software complexity, algorithms, everything we need to be taken care, right? So these are all the data points. You can address all these data points, right? So that way you can implement quantum machine learning very seamlessly in your industry, right? So it can be in any industry, right? So address data challenges, right? So data preparation, right? So preparing a data for quantum processing, right? So that will be I mean we need to encode different effective encoding schemes, right? So that will be so that only it will be beat the beat the classical machine learning, right? So that is very much important for the data preparation, and then they simulate the quantum data generations. So this is one more thing. So we need to make sure, right? So One is the data preparation, and then the simulating the quantum data generations. So these are all the two difference in the data challenges, and then the train personals, right? So I mean, this is very much important, right? Why? Because, right? So um, I mean, we need a employee which they need to know I mean, depth knowledge of the quantum machine learning as well as the quantum computing, right? So that way, that those employees can identify the issues if we need to fix, right? So that will be very much required thing in if we are going to implement quantum machine learning in industry. So if I don't have any skilled person in the industry, so we are always depending on somebody else, right? So that way we need to invest in the training for the employees to know both quantum computing and machine learning. So and then or otherwise we can do like hiring the experts, right? So I mean, this is a different call. Either we need to upskill the employees or hire the experts. So we can do both, or we can do any of the things, right? So based on the company needs, right? So we can do, we can hire the experts, right? So that's also we can do, and then monitor the progress and illiterate, right? So we need to do some pilot project. So we need to compare based on the pilot project results, right? So we need to see if I did it in the classical approach, what is how it looks like. If I did it in the quantum machine learning, how it looks like. So for example, I mean, due to the um, machine learning, I mean quantum machine learning. So what is my achievement? What is the performance metrics I'm having? So with some pilot projects we can do. So with those pilot projects, we can see the difference in the performance metric, whether that performance metric is justified for you, or I mean, based on that call only we need to take the uh, that based on that call only we need to take whether I need to implement the quantum machine learning for this particular field or not, right? So if there is no potential performance metrics, right? So it's a waste of money, or spending in the quantum machine learning. It's a waste of time or money, right? So we need to do a performance analysis before taking in. I mean, before adapting this quantum machine learning, and then iterative improvements. So I mean, based on the pilot projects, right? So we get a lot of feedbacks. So what are all the things we can do? Like, so we can refine the algorithms, workflows, right? So those are all the different things we can, like data preparation wise, what we can do. We need to we need to feed more data, or how we need to improve the performance metrics in the quantum machine learning. So these are the feedbacks we'll get it from the pilot projects if we did the pilot project. So based on that one, we have some metrics, right? So whether uh, uh, quantum machine learning is making changes in this particular process or not. If that is making a process, I mean progress, right? So then we can adopt the quantum machine learning for the particular domain or a particular sector. Okay. So um, okay. So can you, I mean, you can list what are all the quantum programming languages or suites available right now? I mean, um, in the right now, right? For example, as of now, what are all the quantum programming suites or language available? Either Python, Qskate, C++. Okay, I see. I think Python, Qskate, and Circ. So these are all the three available programming suites out of these four. C++ is not under this one. So the first three are in the quantum programming languages or suits available in the market. So right. So okay. Yeah, I'll go to the next one. So limitations of implementing quantum machine learning in industry. So we see the earlier sessions, right? So we see what is quantum machine learning. So why quantum machine learning is required. So how we can implement the quantum machine learning in the industry. So and then we are seeing what are the limitations of implementing the quantum machine learning in the industry. So we see in the how part. So if you for implementation, what are all the things are required? So even though if you implement, so these are all the limitations I am seeing in the quantum machine learning, right? So we'll discuss about the limitations, right? So hardware constraints, right? So as we uh, discussed right earlier slides, right? So hardware complexity, hardware things, right? So hardware constraints, right? So the scalability and reliability, right? So the quantum hardware is it's not scalable and reliable, right, for the practical application. Why? Because right, so this technology is still in the initial stages, right? So that's the reason. So the hardware constraint is always there, and then one more major disadvantage which we discussed in while discussing the quantum machine learning introduction, right? So noise and decoherence, right? So these are all the major disadvantages right now with in terms of hardware constraints, right? So this hardware constraints is still there. So that is the reason different organizations are investing in the R&D for reduce the noise in the quantum machine learning, right? Okay. So and then software compactability, right? So I mean, so the here two different things. So integrating with the existing framework and then the user friendliness. I mean, this quantum architecturals are different programming language protocols, right? So that those are all the different when compared to the classical, right? So that the integration with the existing framework is a limitation, and then user friendliness, right? So quantum programming is one more not familiar areas, I would say, right? So that is the there. I mean, the user friendliness is not. Um, I mean, that is not there in the quantum programming. So it's a difficult, unfamiliar with the most of the machine learning practitioner, right? So I mean, we need to invest in the learning part, or we need to have the high expertise, right? So then only the user friendliness will improve. So hardware, we seen the hardware constraint, what are the software side, what are the limitations we have seen, and then so the algorithmic complexity. So developing a efficient algorithm is also an difficult thing in the quantum machine learning, and then embedded schemings. So these are all the two different things which will be uh, lead to a limitations in the quantum machine learning, and then the theoretical foundations. So we don't have, I mean, the lack of robust theoretical frameworks. So since it's a new technology, it's in the R&D, right? So lack of robust theoretical frameworks, and then understanding quantum landscape is also another limitation. So like for example, understanding of the quantum landscape is very much different. So we need to be very much knowing this quantum machine learning, right? So then only we can make very useful things out of here. So that is also one of the limitations here. And then the data availability wise, so I mean, in the quantum machine learning, so we have only limited availability of the standard quantum data sets. So that can be used for the benchmark. We cannot use every data, right? So data sets in the quantum machine learning. So those are all the. I mean, we need to standardize the uh, quantum data sets that can be used as a benchmark, right? So So that is very less data availability of the quantum data sets. So this is one of the limitations. And one more, cost and accessibility. So this quantum machine learning, quantum machines are very much costlier. Why? Because right, so it needs a cryogenic cooling, right? So maintaining in the cryogenic cooling, right? So that heat should not affect this engine, right? So we need to be in the cryogenic cooling. So the infrastructure cost here is very much high, and then accessibility also it's very less due to the cost and everything, right? So and then the workforce challenges. So skill shortage. So since it's an initial technology like AI, right? So the next I mean the future will be depending on the quantum machine learning, right? So it will change, it will affect each and every industry, right? So skill shortage is the major limitation, right? So we need a professional to work on the quantum machine learning. So without those workforce, we cannot implement the quantum machine learning in the industry. So these are all the different limitations, right, we are seeing here. So as I said, right, so we are seeing a lot of limitation: hardware constraints, software compatibility, algorithmic theoretical foundations, data availability, cost, workforce challenges. So I would say like if we have limitations, so those limitation we can make it as a opportunities for the future, right? So I have given all of the limitations you can see in your phone, right? So which are all the limitation can be seen as an opportunity for the future is. So I have listed all the limitations. So you can see what all the limitations are there. So those limitations can be converted to an opportunity for the future is, right? So that's how the opportunity comes into place, right? So from limitation, that if we break the limitation, that where we can make the opportunity, right? So I have listed all the limitations. You can see it you can see it in your phone or whatever device you are logged in. So out of these limitations, you can you can think and then answer like what are all the limitations can be seen as an opportunity for the future. So what are the limitations we have discussed earlier? So that can be seen in your phone, right? In the Mentimeter. Hardware. Okay. So I would say, sorry. Yeah. See, I have given the things, right. So hardware, software complexity, algorithmic complexity, theoretical cost, data availability, workforce challenge. So I see major opportunity here as like workforce challenges, right? So we need a skilled professional to implement the quantum machine learning in the industry. So workforce wise, we need to, if we focus on the workforce, right? So you will be very much required professional in the industry. So workforce is the very important opportunity for the future, right? So I would say that is the my topmost priority, right? So yeah, I see a lot of responses. Okay, workforce challenges. Yeah. Okay. We'll go for the next. Okay, I think we are going for we are in the end of the session. So if you have any questions, please ask me. Even you can type your questions in the Mentimeter, right? So
There are some
yeah.
questions in the chat box.
Okay. So I'll take it the chat box questions later. I mean, maybe after this one, I'll take that one. So,
Yeah, sure.
so what we can do to, so I'm not getting the question. So in what we were asking, so maybe if you give me some more clarity, right, so that I can answer your questions. So I think I'm not seeing any questions here. Um, I'm okay. So I'll see the chat window and then I'll share my screen. Okay, so how will the quantum machine learning, so disease prediction and diagnostics? Yes, so obviously, so the disease prediction wise, right? So, I mean, still, I mean, there also we need to process a lot of data. Um, so processing larger, wherever we are processing larger data sets, there we can apply quantum machine learning so that we can make it a very faster results and then the very accurate results so that we can make it a very good prediction in the imaging, also healthcare industry also. It's absolutely yes. What are all the regular and standard implication of quantum computing in industry? Like implications wise, the limitations we have talked a lot of limitations, hardware, everything, right? So those are all the implications. What are all the we discussed in the limitations? So those are all the implications. So how we can develop partnership and collaboration between the industry, academic, and the government? I think I mean it's more it's more the business related question I would say. So I mean maybe you can you need to contact with the I mean who are all providing the quantum machine learning. So you need to uh, make a relationship with them, and then um, we need to approach them for the help, and then otherwise we can go for the open source platforms, like I mean not a open source platform. So what are all the um, available hardware and software, even in the softwares are available in the cloud computing, and then through the cloud computing quantum machines also available in the in the cloud platform. So we can leverage, and then we can try it out. We can try some pilot projects on those things, and then we can approach for some industry. So that will be the that way we are giving some confidence to them, so that we have done these are all the project. I mean at least some pilot projects. So with the help of those pilots performance, right? So we can check with them for their support, all those things, right? So instead of going with the nothing, so we can do some pilot projects. That way the industry or some you want to make a partnership with somebody, right? So they will feel confidence, right? So then they'll come for the partnership with you, right? So I think that will be the best way we can do. And then
Thank you, Dhanasekar. Thank you for
yeah,
answering all the queries, and
okay,
wonderfully you
one
have
more.
yeah.
Sorry. Yeah, I think I have one more. Um, sorry, just a second. So this is the final question. Oh, Just give me a moment. So it's okay. Okay. I think you have the Menti, right? So you can. I mean, I ask a lot of questions. Right? So maybe you people. Um, I mean, this. I'm scared right now. So please. I like so whether the session is useful or not, right? So you can please provide your feedback here. I mean, at least some whether this will be useful or not. Okay, I guess.
Thank you so much. It's definitely a useful and interactive session. And I mean, coming to the
Okay.
industry point of view, as far as all the sessions are concerned, technically they have explained. So, industry point of view, you have shared some insights. So, it will be definitely helpful for all of us. Thank you so much for your time and contribution. Thank you.
Okay. Thank you. Thanks a lot. I mean, it's a great opportunity to interact with different set of people, right? So, and then it's a learning for me too, right? So I need to dig into a lot of different quantum machine learning applications. It's a learning both a side. I mean, it's a both way learning, right? So thanks for this opportunity. Thank you.
Thank you so much.